Hello, guys. Welcome back to Math Zone African Motives. We are still on our revisions and we are going to add another question paper as we are preparing for our exams. This was our KZN province and we are given the March 2025, which was their common assessment task, which is the test that they wrote in March. So we are going to look into that and figure out how to attempt typical questions. So it was actually 75 marks. It was 75 and 1.5 hour, 1.5 hours that was required for you to write everything. All right. So make sure that you go through your instructions. All right. Make sure that you go through the instructions. And I just have the questions. I just tried to edit them a little bit because you can see that from the original copy that I had, this one, it was a little bit something else. So you just check properly the values because some of the values can differ because I had to edit so that it can be at least clear. We can clearly see what we are working with. So you can actually download the question paper so that you can properly see the questions and also the memo. Just check the description of the video, or you can check the comment section. All right, I'm going to pin a comment which is going to be having the question paper and the memo. All right, so I'm not going to waste your time, guys. Let us quickly go through our questions. The first part, question 1, we were given 1.1 to solve for x. Solve for x, where we can be given equations, inequalities there. All right. So the first part, 1.11, we are given a quadratic equation. All right. So this is a quadratic equation. X squared minus 3x minus 28 is equal to what? To 0. So that's a basic quadratic equation, guys, where you are not told answer correct to 2 decimal places. You are not told that. So meaning to say factorization can even be applied. Yes, you can use your quadratic formula. It is fine. I'm not saying using the quadratic formula is wrong, but you can simply do your factorization. So in my case, I'm going to factorize this. All right. So this is it. The coefficient of x squared is 1. So meaning to say in our brackets, we're simply going to have x and x for us to obtain what? X squared, x times x. And considering the factors or products of what? Negative 28, our constant. But if we add these, we must obtain negative 3, the coefficient of what? Of x. So what are the products of negative 28 or factors, all right, of negative 28? There are so many, guys. Negative 28 and 1, 28 and negative 1. So many. 14 and what? And negative 2, negative 14 and 2. But of all these factors, there is a pair that we are going to consider of these numbers, like, I mean, of the products that you have. When you add, you are going to obtain negative 3 when you add. So this occurs here on minus 7 and what? Positive 4. If you add these two, you are going to obtain a negative 3. So that's negative 7 and positive 4. So thus, we can solve for x. Minus 7 to the other side is going to be a positive, or x is equal to positive to the other side is going to be a negative. So this is negative 4. So these are the values of x that we're going to have from our quadratic equation that we're given. All right, so let us consider another part of the question, which is a continuation, 1.12, given that 6 into 1 plus 2 over 3. 2 over 3x is equal to 3x squared. So yes, we've got a quadratic equation. The highest exponent is 2. But guys, we can see that the R bracket, there's a bracket there. So let us consider expanding or removing this bracket by simply distributing by what? By the number that is outside the bracket, which is 6. So it was going to be 6 times 1, which is 6. All right, then here it's a positive. 6 times 2 over 3, you can even use your calculator. 6 times what? 2 over 3. This is going to give us 4. So that's 4x. All right, take note, we have got x there. So this is equal to 3x squared. All right, so remember, guys, the format of our quadratic equation: ax squared plus bx plus c is equal to 0. One side of our equation is supposed to be what? Equal to 0. So that's one side of the equation. So what we can do, since here our coefficient of x squared is positive, we've got a positive 3, we can simply take other terms to the other side of the equation. So that's 0 is equal to 3x squared. 4x to the other side is going to be negative 4x. All right, positive 6 to the other side is going to be a negative 6. Remembering, guys, if a is equal to b, it simply means b is equal to a. So meaning to say, I can simply take this whole part as it is and equate to what? To 0. 3x squared minus 4x minus 6 is simply equal to what? It is simply equal to 0, guys. There's nothing that has changed. We just wrote this to the left-hand side where we are used to. So now we can use our quadratic formula, all right? Or you can use completing of the square method. It is up to you, all right? Never try factorization when they are telling you this to 2 decimal places, all right? So thus our x from the quadratic formula is equal to minus b. So this is ABC. All right, a, the coefficient of x squared, b, the coefficient of x, which is what? Negative 4. And c is our constant, which is what? Negative 6. So that's x is equal to minus. Remember, b is what? Negative 4 plus or minus the square root of b squared. Our b, that's negative 4 squared minus 4 times a. Our a is 3. And our c is what? Negative 6. Everything over 2 times a, which is 2 times 3. All right, so that was it. Yes, you can just use your calculator at once, determine the values, or you can simplify this part that is under the square root. All right, so it was going to give us... right, you can just simplify. Some of you guys want us to just simplify at once. Minus 4. All right, I'm going to start with a plus on that one, plus the square root of open bracket, just as it is on your presentation, guys, as it is, minus 4, open bracket, put 3, open bracket, minus 6, all right? Everything over 2 times what? 2 times 3, as it is here. So this is what you're going to have as a decimal 2,23. All right, to 2 decimal places, that's 2,23, or you can just fix your calculator to 2 decimal places. All right, 2,23. Or x is equal to, I'm just going to change here and put a negative. All right, let us have a negative on this one. So that is going to give us negative 0,902, 2 decimal places. 90. You must have that 0 there. All right, so these were our solutions to 2 decimal places from that quadratic equation. All right, so as we can see, guys, just play around. The format is very, very important. All right, for you to have the format, check or look into the format first before solving. All right, once you have the exact format that you are used to, you can simply solve directly your equations, even inequalities. All right, we have got an inequality on 1.13. That's 2x squared plus x minus 3 is greater than or equal to 0. So what you can do as you are working with an inequality is to find the critical values, all right, which we can solve. All right, so here we can simply factorize and see what you're gonna have. Let us try to factorize. So on factorization, guys, here on factorization, apply the way that you understand. All right, you've done different ways of factorization. All right, so as for me, I'm just gonna use the quicker way, the cheat method. Remember this one, we have to get rid of 2. It multiplies 3, so it's gonna be x squared plus x. 2 times 3, that's what? Negative 6. So we removed this 2, it's no longer there. So what is it that you have? You've got this part which is easier for you to factorize because the coefficient of x squared is what? Is 1. So it's easier for you to simply factorize x, and x here you consider what? The factors of what? Of negative 6, which will give us a positive 1 when we add them here, the coefficient of x. So factors of negative 6, there are so many factors, guys, so many factors that we can consider. But of these factors, which part, when we add, we are going to obtain a positive 1. So this is between 3 and what? Minus 2. 3 plus minus 2 gives us a positive 1. So that's plus 3 minus 2. All right. So remember, we removed the 2 before by multiplying it to the constant. So now you must replace the 2. All right, in place of x. Remember, this is on x squared, so you substitute in place of x. All right, in both brackets you're gonna put that 2 back here and also here, and factorize where possible in these brackets. All right, so you can see that the second bracket 2 is common, so I can factor out 2, and that is going to give us 2x divided by 2, that's x minus 1. And this bracket, the first bracket, we do not have any common term, so you're just going to rewrite as it is. All right, the 3 that is outside, I mean this 2 that is outside, is not part of your solutions, is not part of your factorization. This number is useless. You cancel it. You take only the brackets. So meaning to say, we're going to have what? X minus 1 and 2x plus 3, just like that. So this is the cheat method. But like I said, guys, factorization, there are so many ways, and you guys can cheat in so many ways. So try to apply it the way that you understand. All right, so that is what we have. So we've got x minus 1. Now we're going to determine the critical values, where x is going to be what? Negative 1, to the other side is going to be a positive. Or if we solve 2x plus 3 is equal to 0, it's going to be 2x is equal to 3 to the other side. That's a negative 3. Divide by what? By 2. So x is minus 3 over 2. So that was going to give us the value of x. And with these critical values, we can determine the exact solutions. Are you going to use the number line? Are you going to use the graphical method? Using the graphical method, here, the coefficient of x squared is greater than 0, so it's going to be concave up. So our graph is concave up. We're having two different solutions. Minus 3 over 2 is going to be on the negative side, and this is positive 1. And we are given that this whole part is greater than or equal to 0. It is greater than, meaning to say it is what? Positive, above the x-axis. We need the region that is what? Above the x-axis. So this is our x-axis, remember. So above, that's our solutions, will be this side and this side. So that is it. values that are to the left side of -3, they are what? Less than -3. So therefore x is less than or equal to, there is an equal to on our question. So it's less than or equal to -3 over 2. Or we are going to have another x values which are to the right side of 1, they are greater than 1. All right, they are bigger than 1. So x is greater than or equal to 1. That will be another solution. So make sure, guys, you do watch the videos on the introductions. All right, I have worked these introductions so that you can understand different ways of answering. All right, the number line, anyone, but your solutions will be the same. So just try anyone. Where you do not understand, let us communicate. The comment section is there. Let us move on to another question, 1.2. So here something happened. I'm going to correct it. All right, let's see. 1.2, we are given this. It was it was just a repetition. All right, no problem. I'm going to show you how it was supposed to be like. All right, this was 1.2. All right, where you're being asked to solve for x. All right, this was it. 1.21, it was to solve for x. All right, so this one, just remove it for now. This part I'm gonna show you how the question was like, the continuation. All right, so how can we solve for x given that the square root of x minus 3 is equal to 2 over the square root of x? All right, remember these sets. We are dealing with what? With sets, and we can actually solve for x. All right, let's consider to say we've got a fraction. So let us get rid of the fractions by what? Cross multiplying. So that was going to be square root of x multiplying the square root of x minus 3, right? The square root of x minus 3, which is equal to 1 times 2, which is 2. All right, there we have got a law as we are dealing with sets. Remember that the square root of a times the square root of b is equal to what? Square root of ab. You have to multiply these numbers under the square root. So x is going to multiply x minus 3, all right, for us to have it as a single set. So it's going to be x multiplying what? X minus 3. X multiplying this x minus 3. All right, so this is equal to what? This is equal to 2. Okay, that is equal to 2. So what we can see here is that we have a single set on one side of the equation. That's a single set that we have. So what we can do is to get rid of that square root by what? Squaring both sides. So we have to square both sides. By squaring, you are getting rid of what? The square root. So meaning to say you're going to remain with what is under the square root. X into what? Into x minus 3. And that is equal to 2 squared. 2 times 2, which is 4. All right. So that's it, guys. We can solve for x. As we can see, there's a normal equation where we can expand our brackets and see what's going to happen later on. So here we're going to obtain x times x, which is x squared, x times minus 3, that's minus 3x. That's a quadratic. So definitely we're going to need to take the 4 to the other side as for us to maintain the format that one side must be equal to 0. So this is what you're going to have. It was going to change to a negative what? 4. Then we can solve for x because this is a normal quadratic equation. You can use your quadratic formula. You can use your factorization as we have the coefficient of x squared being 1. This is going to be x. Then what are the products of negative 4? Which will give us a negative 3 when we add. So what we need are the products, the factors of what? Negative 4. Negative 4 and 1, 4 and negative 1. But of these factors, when we add, which one is going to give us a negative 3? That's negative 4 and 1. If we add this, we are going to have what? A negative 3. So that is minus what? Minus 4 and plus what? Plus 1. So these are the brackets that we are going to have after what? Factorizing. So we have to factorize and obtain these two brackets, and we can determine our values of x. Minus 4 to the other side is going to be a positive, plus 1 to the other side is going to be a negative. So these are the values of x from solving the quadratic equation. But remember, guys, this equation that we're solving is under seds. Remember here. So we have to test from that original equation that we had. All right, we have to test our values to say which one is it. Remember, our original equation was the square root of x minus 3 is equal to 2 over the square root of x. So let's test when x is what? Is 4. So the left hand side, square root of 4 minus what? Minus 3. All right, it's because I fixed my calculator to 2 decimal places. Let's get it to the normal mode. So that's what? A 1. Is it equal to 2 over what? Square root of x. So it's 2 over the square root. Our x, remember, is what? Is 4. So this is going to give us a 1. So truly, 1 is equal to 1. So x is equal to what? To 4. All right, we move on to the other one when x is negative 1, guys. By just putting a negative here, we can see that we do not have a solution. We cannot determine the square root of a negative. So x can never be equal to what? Negative 1. So that's only the value of x that we're going to have is what? A positive what? A positive 4. That is the condition of our question. All right. Then the other question, this is what I was wanted you to see here. It was just a mistake. Remember, I had to edit these questions so that they can be clear. So in editing now, this is where these things happen, where sometimes the software removes what? Other values that are important. Remember, we said x is equal to what? X is equal to 4. I want you to understand this one. Here they're saying 1.22. It was hence or otherwise solve for k if. All right, this is not the one that was given. Let me just rewrite our original question here. Sorry for that. This here, it was that if we are given that the square root, right? If we are given that the square root of x minus 3 is equal to 2 over the square root. Sorry, the one that we are now solving is, remember, I'm also writing the wrong thing here. It's k minus 20, all right, is equal to 2 over the square root of k minus 17. All right, so just download the question paper, guys, from the description of the video or the comment section so that you can see exactly the questions that were given. All right, here it is because of those editing that I was trying to make it clear. So this was our question. They are saying we must solve for k if these two are equal. All right, and it was actually 2 marks for that. It was just 2 marks. So you wonder to say, why 2 marks? All right, I want us to see something here. You remember, it is hence or otherwise. So I want us to use the hence continuation. All right, so this was it. If you check properly, this presentation is the same as the presentation that we were given before. The square root of x minus 3 is equal to 2 over the square root of x. Are we seeing it is same presentation? So what does this tell us, guys? It simply tells us that we can equate as it is here. We can see this is 2. This is also a 2. What we have there is something under the square root. This part under the square root. This is also under the square root. So these two can be equated 2 over what? The square root, 2 over the square root. So there's no way, guys, what is under the square root is supposed to be the same. So x is equal to k minus 17. That is what we can tell from here. The same thing here, we could have worked it from the left-hand side of our equation. Since the right-hand side is the same, it means also on the left-hand side, we're going to have the same concept. We have a square root here, we have a square root here. So what does it mean? What is under the square root is the same here. What we have under the square root, k minus what? Minus 20 is equal to x minus 3. That is what we can conclude. These two are same presentations, only that here it's written in k, here it's written in terms of x. So equate those. So what is the advantage, or what is the use of equating this? The advantage is that we have already calculated the value of what? Of x. We have already the value of x. Remember, for those solutions, we said x can only be equal to what? X can only be equal to 4. So substitute that when x is what? When x is 4, and solve for k. If x is what? Is 4. What is going to be the value of k? That's it. So minus 17 to the other side, that's a positive 4 plus what? 17 equal to k, so that's 21. Just like that. Or you could have worked it from this side. For that value of x that we are given, k minus what? Minus 20 is equal to, in place of what? In place of x, we said our x is what? Is 4. So it was going to be 4 minus what? Minus 3. So k minus 20 is equal to 4 minus 3. That's a 1. Let us take minus 20 to the other side. It's going to be what? A positive. So k is 1 plus 20, which is what? 21, just like here. So this is the value of k. We can solve it anyhow. This is to show you that exactly what you're doing is correct. From these two, if we were going to determine different answers, it was going to be wrong, because they said solve for k. It means we do not have possible values. It's just a single value of k that we have. And that was what? That was positive 21. So expect these typical questions in your exam. All right, let's move on. 1.3, we are given solve simultaneously for x and y. All right, this is x squared minus 15 is equal to minus 5xy minus y squared. All right, so that is it for us to solve here. What we can see, guys, is that we have got two equations. Equation 1, which is a linear equation, and we have got equation 2, which is a quadratic equation. So remember that, guys, I told you that when you've got this condition, what you can do is to play around with the substitution method. All right, you use substitution method, where you can make x or y the subject from the linear equation. All right, so what I can simply do is to make y the subject from the linear equation. I'm going to take it to the other side, so it's going to be positive. Take 3 to the other side, so it's going to be negative, so it will be 2x minus 3. So I have made y the subject. Y is equal to 2x minus 3. This is now our equation 3. Using the substitution method, as y is the subject of the formula, what we can do is to substitute this equation 3 as it is into equation 2. Remember, we made the subject from equation 1. So we substitute into the other equation. That is what? Equation 2. In place of what? In place of y. Wherever we have got y in equation 2, we are going to what? We are going to substitute that one with what we are given here, 2x minus 3. So thus, this was going to give us x squared minus 15 is equal to minus 5x. All right. And y is represented by what? 2x minus 3. So we must open a bracket for that. All right. So that's 2x minus 3 minus y squared. So that's minus y is what? 2x minus 3. But this is what? Squared. So this is our quadratic equation that we are left with. Let us expand the brackets and try to simplify further. Here we have got a bracket that is to be affected by what? By negative 5x outside of the bracket. So that means we were going to have negative 5x times positive 2x is going to give us negative 10x squared. All right, negative 5 and negative 3, that's a positive, negative, negative. So that's positive 15x. Minus, expand this bracket, the two brackets, x squared. I mean, the squared means you've got two brackets that you can actually expand, or you can simply expand direct. Remember, a minus b squared is equal to what? A squared minus 2ab plus b squared. So that's our a is what? 2x. Our b is what? Is 3. So this is ab. So a squared, it means what? 2x squared, which is going to be 4x squared. You have to square that as it is. So that was going to give us 4x squared minus 2ab. So that's minus 2 times a. A is what? 2x, and b is what? Is 3. So that's negative 4 times 3, negative what? 12x. And the last part is the last term squared, b squared, and our b is 3. So 3 squared is what? 9. And that is going to be positive. All right. So this is what you're going to have after expanding. And still, we can expand it further because we have got a bracket here on the right hand side. So we have to expand this bracket by the negative outside of the bracket. So that is simply a negative what? A negative 1 that we have. So we must expand. X squared minus 15 is equal to minus 10x squared. All right, plus 15x. Then let us expand. Minus 1 times 4. So it's negative 1 multiplies 4, which is minus 4x squared. Minus 1 and minus 12, that's a positive 12x. Minus 1 and positive 9, that's a negative what? 9. So collecting our like terms on the right-hand side, we have to simplify further. Let us collect our like terms. We've got this part of x squared minus 10x squared and minus 4x squared. These are like terms, all right? So minus 10 minus 4, that was going to give us minus 14x squared. Then we have got 15x and 12x. These are also like terms to be considered. All right, 15x and 12x. You have to add these two. 15 plus 12 is going to give us what? 27, positive 27x. Then we've got what? A negative 9. So here it was issue of just collecting like terms from what we had. But after that, we can see that this is a quadratic equation. So we are going to need the format ax squared plus bx plus c is equal to 0. One of the sides must be equal to 0. So what we can do is to take our terms. This is negative. Let's just avoid to be negative. Let's take our terms to the left side. So we've got x squared there. So it was going to be 1x squared plus 14x squared, which is what? 15x squared. All right. Then we take the 27 to the other side. Is going to be what? Negative 27x. Negative 9 to the other side is going to be a positive. So it was going to be minus 15 plus 9. These are like terms. All right, minus 15 plus 9, that's a negative what? Negative 6. So that was going to give us a negative 6 equal to 0. We no longer have anything on the right-hand side. So that's the basic thing that you need, the format of the equation. So we can solve it using quadratic formula, or you can just try to reduce this here by what? By 3. 3 is the highest common factor, so that was going to be 5x squared minus 27 divided by 3, that's negative 9x. Minus 6 divided by 3, that's negative 2, which is equal to 0. So with this equation that we have, we can simply solve, guys. Use your quadratic formula, factorization, whatever that you want. So as of the factorization, guys, still as for me, I'm just going to apply that cheat method. Remember, we have to get rid of this 5 here to multiply. So it's x squared minus 9x minus 10. 2 brackets x factors of negative 10, which will give us negative 9. When you add, it's negative 10 and 1. So if we add, we're going to get negative 9. So that's negative 10, positive 1. Then we have to bring back the 5 in place of x. So we're going to put 5, we're going to put 5, and factorize where possible. So the first bracket, 5 is common. So 5 and 5, we're going to have x minus 10 and 5, that's negative 2, and this is 5x plus 1. All right, so this is it. The 5 that is outside of the bracket is not important. So these are the brackets. What is inside of the bracket? X minus 2, 5x plus what? Plus 1, just like that. So that is it. Minus 2 to the other side, that's a positive. Or x is going to be what? 1 to the other side is going to be negative 1. Then you divide by what? By 5. So these are the possible, these are the values of x that we are going to have two values of x. So it was actually solving a quadratic equation. At the end, we had to solve, sorry for that, we had to solve the quadratic equation that's having two possible values. And here we must solve for x and what? Y. X and y, remember? So we must solve for y this time. So which one can we use? We can simply use equation 3. Remember equation 3, we made y the subject of the formula. So we can simply work with that one. From these solutions, we can simply use y is equal to 2x minus 3 to find the y values. When x is 2, put that in place of x. That's 2 times 2 minus 3. That was going to give us 4 minus 3, which is 1. Or y is equal to, in place of x, if our x is what? Negative 1 over 5, like this, minus 3. We're going to obtain the value of y just like that. 2 into negative 1 over 5. All right, then we're going to subtract 3. This is negative 17 over 5. Negative 17 over 5. So these are the values when x is 2, y is equal to 1. When x is minus 1 over 5, y is equal to what? Negative 17 over 5. So different ways of answering these questions, guys. Just do revise. These are simultaneous equations. Yes, sometimes it can be a strength thing that you have to work out a lot of things, equations, rearranging of equations, expanding of brackets, collecting of like terms. In one question, they will be testing all those. It can be like that, like what we just saw on this one. All right, anyways, let us move on. 1.4, there was an equation. An equation is given by this, all right? So you see these things of editing, guys. This one was just a repetition here. An equation is given as, all right, 1.41, solve for x in terms of m. From this given equation that we have here, 1.41, we're asked to solve for x. Given half x squared plus mx, all right, plus 18 is equal to 0. So you can actually solve for x, guys, using your quadratic formula direct. This is your A, this is your B, this is your C, all right? even with the fraction, there's no problem. So I want you to do that. Or you can clear the fractions, as we have got what? A fraction here, 1 over 2. So it follows that the LCD of these fractions will be what? A 2. So you multiply by the LCD or the LCM each and every term. Multiply by 2, multiply by 2, multiply by 2 by 2. So this was going to cancel. And you have got 1 times x squared, which is x squared. 2 times m, that's 2mx. 18 times 2, that is what? 36. And 0 times 2, that's a 0. So at least we no longer have fractions, so we can simply solve. It's another way, but you could have just solved direct as it is, all right? So they said using the this equation, so you can just use the quadratic formula. X is equal to minus b plus or minus the square root of what? B squared minus 4ac over 2a. So a is the coefficient of x squared, which is 1. B, the coefficient of x, which is 2m, and c is our constant. So meaning to say x is equal to minus b, which is what? 2m, plus or minus the square root of b squared. Our b is what? 2m, so that's 2m squared, minus 4 times a, which is 1, times c, which is 36. Everything over 2 times a, which is 2 times 1. All right, so I can simply solve this further. Minus 2m plus or minus, I have to square this, 2m squared. Remember, we have to raise everything to the power of 2. 2 to the power of 2, that's 4. M to the power of 2, so that's 4m squared. All right, minus 4 times 1 times 36, just multiply here. 4 times 36 is what? 144, but there is what? A negative, so that's negative 144 over what? 2 times 1, which is 2. Can we solve further this equation that we are given now? We can just leave it like that. We have got our equation in terms of m. Remember, they said we must solve in terms of m for 2 marks. It will be fine. Then, hence or otherwise, determine the value of values of m for which the above equation will have what? Equal roots. That's 1.42, nature of roots. For this equation to have what? To have equal roots, what will be the values of m? So that's a continuation, guys. So remember, from the nature of roots, guys, for you to have equal roots, the discriminant must be equal to 0. Our delta is directly equal to 0, right? So make sure you understand that part. And our delta is already calculated. This is the part that we have here under the square root, the part representing what? B squared minus 4ac. So we already have our delta, which is what? 4m squared minus 144. But we are saying in order for us to solve these two, they must be equal. For equal roots, our delta must be equal to 0. So meaning to say, therefore, 4m squared minus 144 representing our delta is equal to what? Is equal to 0. Directly equal to 0. So we can solve our equation. Yes, so many ways that you can use. You can even reduce your equation. Just divide by 4 by 4. That's m squared minus 144 divided by 4 is 36. All right, and that's equal to 0. This is a difference of 2 squares. You can easily factorize the square root of 36. That's 6. One subtracts another one, it adds. So you're going to have two possible values of what? Of m. Minus 6 to the other side is going to be positive. Positive 6 to the other side is going to be a negative. So these are the two possible values of m. That is what you're going to have from the given equation. All right, so you see, guys, it's just a repetition. They do repeat these nature of roots, just different equations, but the concept is just one and the same. All right, question number 2, evaluate the following expressions without using a calculator. No calculators, guys. All right, so 2.11. Right, we can simply just work it as it is here. The square root of 121 is 11. And the square root of x squared, remember the square root and x squared, this neutralizes. So you're going to remain with x minus the cube root of 27, that's 3. And what about the cube root of x cubed? This simply neutralizes, so just get rid, you remain with x. So that's it, over what? Minus 4 to the exponent of 0, that's minus 4 to the exponent of 0 is what? Is 1. And there is what? And there is x. So it was going to be minus 1x, which is minus x. So take note, guys, it's not minus 4 to the exponent of 0, no. Minus, then 4 to the exponent of 0, it's on its own. So minus, but any number to the power of 0, it's 1. So it's going to be minus 1. So that's it. 11 minus 3, these are like terms. So 11 minus 3, that's 8. X over minus x. So here x and x can simply cancel. So you've got 8 over negative 1, which is what? Which is negative 8 at the end. All right. So that is how we can have these typical equations. Then considering 2.12, all right, this was k minus 1 here, k minus what? K minus 1. All right, so it's 8. All right, let us just have it here. 2.12, it's 8 times. It's actually 8 to the exponent of k. Please, guys, can use the question paper. Check properly from the question paper. It's 8 to the exponent of k. All right, so let's correct that. 6 to the exponent of k minus 3. 9 to the exponent of 1 minus k. Everything over 16 to the exponent of k minus 1 times 3 to the exponent of what? Minus k. All right, so yes, we can simplify this one. The best way is to have your numbers in simplest form. All right, just have your numbers in simplest form. So 8 is 2 to the exponent of what? 3. Or you can just use your calculator. 8 is equal to, then you press this shift fact. All right, shift, you press the fact button. That's 2 to the exponent of what? 2 to the exponent of 3. But already there is what? There is a k that we have. So it's just going to multiply. So it's going to be 3 to the 3k times 6. All right. So 6 is same as what? 2 times 3. But you can simply use the same concept. 6 is what? 2 times 3. So that's 2 times 3 to the exponent of k minus 3. All right, then 9 using same, it's going to be 3 squared. All right, 3 to the exponent of 2. Then there is exponent what? 1 minus k. All right, everything over 16. That's 2 to the exponent of 4. But there is exponent what? K minus 1 times 3 is already in simplest form. That's a prime number, so you cannot simplify it further. All right, so what can we do where we are here, guys, is that we can use the laws where it is applicable. 2 to the exponent of 3k, I'm just going to rewrite that one as it is. But on this part here, we can use the law ab to the exponent of n follows that everything can be raised to the exponent of n, a to the exponent of n times b to the exponent of n. So meaning to say 2 can be raised to the exponent of what? Of k minus 3. And also 3 can be raised to the same exponent of what? K minus 3. All right? Times, here there is a law, an exponent and an exponent you multiply. X to the exponent of a to the exponent of b is x to the exponent of ab. You multiply them, exponents. So here it was going to be 2 into the bracket. So that's 3 to the exponent of 2 times 1, which is 2. 2 times minus k, that's minus 2k. All right. everything over what? Our same concept here, exponent and exponent. So you're going to multiply. So it's 2 to the exponent of 4 times what? This part of k minus 1. So that's 4 times k, which is 4k. 4 times minus 1, which is minus 4, times 3 to the exponent of what? 3 to the exponent of minus k. All right, so this is what we have. And those laws of exponents can also be used. Remember, when we are working with the multiplication, same basis, you are multiplying, you are going to add the exponents. But when it is a division, you subtract the exponents, provided that the same, we are dealing with what? Same basis. So this is it, guys. 2. We have 2 here. We have got 2 here. These are under a product in the numerator as it is. It's a product. But there's another 2 here in the denominator. So the ones that we have in the numerator, we are going to add the exponents because we are multiplying same bases. So here, these 2, we are multiplying what? Same bases. So let us add our exponents. 2 to the exponent of 3k plus we add the exponent what? K minus 3. But do not forget, we have a division again because this is in the denominator. So whatever that you have in the denominator must be subtracted. The exponent there, you subtract it. So you're going to subtract the exponent of what? 4k minus 4. All right? So that is the concept. You are done with the 2. Then we move on to 3. 3 is also to be considered. There is a 3 here, there is a 3 here, there is a 3 here. All right? In the numerator, what is happening? In the numerator, you're going to add the exponents as you are multiplying. You're going to add the exponents k minus 3 plus the exponent of what? 2 minus 2k. All right? Then the denominator, this one is under division, so we must subtract. All right? We are subtracting what? Minus k. We must subtract that. Division, remember our law. So you're going to simplify these exponents as it is in the numerator there. So this was going to give us 2 to the exponent of what? Let us just expand. This is 1. So that was going to be 3k plus k minus 3. All right, expand by negative 1 here. That was going to be negative 4k, negative plus a what? A 4. So this is it, guys. 3 plus 1, that's 4, minus 4. So this is going to give us a 0. All right, minus 3 plus 4, that's what? That's a 1. So this is going to give us 2 to the exponent of 1. All right, times 3 to the exponent of what? We do the same thing. This is k minus 3. This is 1. Expand bracket, just going to remain as it is 2 minus 2k. Minus and minus, that's a positive. All right, so you're going to add 1 and 1. That's going to be 2k minus 2k. So as you can see, the k was going to cancel. And you remain with what? Minus 3 plus what? Plus 2, which is minus 1. All right. So that was it, guys. After simplifying these numerators, 2 to the exponent of 1 is same as what? Is same as 2. But 3 to the exponent of 1 is what? 1 over 3. So this is just a direct multiplication. Numerator to numerator, that's a 2. Denominator to denominator, that's a 3. So this was going to give us 2 over 3 at the end. All right, simple mathematics, but you just have to revise, guys, for it to be that simple. You must revise. All right, do as many questions as you can. All right, so let us move on to solving of equations without using a calculator. This is a continuation. We are given here to solve the equation without what? Without using a calculator. And that was 2.21. This was 2x to the exponent of minus a third, which is equal to 3. All right, there we need to solve for x. So 2 is actually affecting. So let us get rid of this 2. Simply divide by what? Simply divide by 2. So x to the exponent of minus a third is equal to 3 over 2. So how can we solve when we have a rational exponent like what we have this fraction? What we can do is simply find its reciprocal. All right, the reciprocal of what? Minus 1 over 3. So what is the reciprocal of minus 1 over 3? It is 1 over that, minus 1 over 3. The reciprocal of what you're given is simply 1 over that. 1 over what? The reciprocal of what? Of minus a third is going to give us what? Negative 3. So that is our reciprocal, negative 3. So you raise to the exponent of negative 3. This one also to the exponent of negative 3, the reciprocal of that. So that when you are to multiply here, you are going to have 1. All right, remember, a number to its reciprocal gives us a 1. Minus 1 over what? Over 3 times what? Negative 3 is going to give us a 1. And this is equal to 3 over 2 to the exponent of minus 3. From our laws of exponents, it follows that a over b to the exponent of negative, when it is just a negative exponent, let's say negative n, it can be written as b over a to the exponent of a positive n by simply interchanging that fraction. The exponent changes to a positive. So we can simply interchange this, and it's going to be 2 over 3. And the exponent changes to a what? To a positive. This one, it is going to be positive 3. So thus we can have our x value. That's 2 to the exponent of 3, which is 8 over 3 to the exponent of 3, which is what? 27. So you raise every term, every number inside the bracket to the given what? To the given exponent. All right. It was just like that. Then let us move on to 2.22. Again, we are to solve for x, and these are two brackets equal to 0, guys. A times b to be equal to 0. A must be equal to 0, or what? B must be equal to 0. So it is either one of these brackets must be equal to 0. The 5 to the exponent of x minus this, or this one. All right. Sorry, here it is like this, guys, the way that they wrote here. Let me correct. It is 5 to the exponent of x, like this, plus 1. Plus 1 is not an exponent. So can we correct the presentation there? All right. So from this concept, guys, I was simply going to apply it to say one of these must be equal to what? Must be equal to 0. So it is either the first bracket where we have got what? 5 to the exponent of x minus 125 is supposed to be equal to 0, or 5 to the exponent of x plus 1 is equal to 0. All right, so let's try to solve for x from the first one. You can take the minus 125 to the other side of the equation. 5 to the exponent of x is equal to 125. And this, we can have them in the same base and equate our exponents. So 5 to the exponent of x, 125 in the base of 5 is same as what? 5 to the exponent of 3. Or you can just use your calculator. 125 is equal to, then shift effect, 5 to the exponent of what? Of 3. This gives us x is equal to 3 because the bases are the same. So automatically our exponents will be the same. X will be equal to 3. On the other hand, if we are to do the same thing, taking 1 to the other side, it was going to be a negative 1. So 5 to the exponent of x is equal to negative 1. Guys, is it possible that we can replace this with a certain number? No. Minus 1. We cannot have 5 to the exponent of x giving us a negative 1. This cannot happen. And we cannot rewrite this minus 1 as a number in base of 5 raised to an exponent. It is impossible. So that's this here. We do not have what? Solution on this part. No solution. So the only one was going to be x is equal to 3. From the first one, we have a solution. So that is going to be our x value, which is what? Which is 3. All right, just like that. Just like that. 2.3, we were given this statement, all right? So play around when you've got questions like these, guys. You play around with them and understand, like, what are they trying to do? It is given that 4 to the exponent of m is equal to 6. And at the same time, 6 to the exponent of n is equal to what? Sorry for that. 6 to the exponent of n is equal to 8. Calculate the value of mn, the product of m and n. If, guys, if it was possible here, I was going to solve for m, solve for n. But it's difficult, guys. How can we have these in the same basis? It's impossible. Here in the same basis, it's impossible. But let's say we had something like that, where we can solve to say m is equal to 2, n is equal to 7. You simply multiply these two to obtain mn. But due to the equation that we have, it is impossible for us to solve like for our level there. Yes, it can be solved, but we are restricted due to the methods that we have in our syllabus. So that is why I'm saying, as for you guys, the method that was supposed to be used to solve, you are not allowed. You are not yet allowed to use that. It is a mathematically proven, but for your level, it is something else, all right? So that is why I'm saying it's impossible. Not to say you cannot solve that. No, it can be solved, but for your level, let's just say it is not. All right. So because of that, try to figure out any other way of solving. I can see that if I have m and multiply this by n and also multiply by n, I have mn. Or from this equation here, if I multiply by m and I multiply by m here, I'm going to have mn. But in doing so, look for a proper substitution. 6 to the exponent of n can be obtained from 6. There's a 6 here. We can obtain 6 to the exponent of n by simply raising this to the exponent of n. But remember, it's an equation, guys. Whatever that you do on the right-hand side must also be done on the left-hand side. So meaning to say, we had to raise our equation to the exponent of n, the left-hand side and the right-hand side. So look at the magic. 4 to the exponent, this is exponent to exponent, so multiply m times n, that's mn, is equal to 6 to the exponent of what? Of n. This is what we wanted. Why is it that we wanted 6 to the exponent of n? Because it has an equivalent value which is numerically given as 8. So in place of the same 6 to the exponent of 8, we can replace it with its numerical value, which is what? Which is 8. This is easier now for us to solve for mn. All right, it is easier. We can simply write these two in the same base. 4 in simplest form, that's 2 squared. 2 to the exponent of 2. There is what? mn already. Is equal to 8 in simplest form. 2 to the exponent of what? Of 3. Remember what I just said before. If these bases are the same, automatically the exponents are equal. So 2mn is equal to 3. So we can solve for mn. Remember what we want is mn combined. So mn is here. So we can simply divide it by what? Divide by 2. That's to cancel. So therefore mn is equal to 3 over 2. So that is how we can solve. This was a play around type of a question where you play around the information, figure out how can you work it out. So if you've got any other way that you have used obtaining the same answers, let us communicate. The comment section is there for that. All right, so that was our question number 2. The whole of it with what? 16 marks. Let us move on to question number 3, the trigonometry part. All right. Question number 3, 3.1, an interesting question here. All right, this is an interesting question. We are given that 13 cos beta is what? Is equal to 5. 13 cos beta is equal to 5. This is what you're given. This is a given statement. 13 cos beta is equal to 5. So we can have the ratio of a cos beta there. Cos beta is equal to what? Simply divide by what? By 13 by 13. So it was going to be 5 over 13. This is what we have for our beta. And alpha plus beta gives us 90 degrees. Angle alpha and beta gives us 90 degrees. What does it mean about these two angles? These are complementary angles, two angles which add up to 90 degrees. These are what? Complementary angles. And they must be found in a right-angled triangle. And both are acute angles. Beta is acute, alpha is also acute. So by making use of a sketch, we're going to see that because these are acute angles, guys, we can just have this in the first quadrant, or you can just draw a triangle. What we just need here is a triangle. And our alpha and beta, remember it's a right angle triangle here, but there are two angles here, alpha and beta, which we are told that they give us what? 90 degrees. If you add these two angles, you must have what? 90 degrees. That's complementary angles. And that's it for us to have 180 degrees for a triangle. So if you choose to say this is your beta, this is going to be what? This is going to be alpha. All right? So according to beta, we are given that cos beta is 5 over 13 from our SOHCAHTOA concept. This is a cos adjacent over what? Hypotenuse. So it tells that according to beta, this is our adjacent. Beta and 90 degrees are adjacent to each other. So this is 5. Hypotenuse is not affected, all right? But according to alpha, guys, 5 is not adjacent. 5 is what? Is opposite. So you must take note according to the angle that you are working with. So this is what we had from the given information. But the question is, out of that sketch and without the use of a calculator, can you calculate the value of this? Tan beta over what? Cos alpha. Can we determine that? The tan of beta over the cos of what? Alpha. Yes, we can. If we can fill in our triangle, all right, then apply our trigonometric ratio concept as we have here. So how can we fill in? All right, remember this is x, this is y, this is r. So you know that r squared is equal to x squared plus y squared. So our r is 13, 13 squared. Our x is 5, 5 squared. The y value is the one that we do not have. 13 squared is 169. 5 squared is 25 plus y squared. So let us take the 25 to the other side of the equation. So it's going to be 169 minus 25, which is 144. So it was going to give us 144, which is equal to y squared. So to determine y, simply find what? Square root of this. So that's y is equal to the square root of 144 plus or minus 12. But y, the y that we have is what? above, yes, according to this triangle, so on this side, so it's going to be positive 12. We're going to take the positive 1. So that's the y value. So we're going to determine tan beta. All right. So the tan of what? The tan of beta. Tan is opposite over what? Opposite over adjacent. According to beta, this is our opposite. All right. 12, the one that faces the angle that you're given. So that's 12 over adjacent is what? Is 5. All right. Then the cos of what? The cos of alpha. Cos is what? Adjacent over hypotenuse. According to alpha, according to alpha, the adjacent is what? Alpha and 90 degrees, they are adjacent to each other on what? On 12. So that's 12 over the hypotenuse, which is what? Which is 13. So these are the two that you need here. The tan of beta, which is 12 over 5, over what? The cos of alpha, which is 12 over 13. All right, so this is a division, guys. We can simply multiply. The moment we do that, we invert the second fraction, we swap, we interchange that. So it's going to be 13 over 12. So these two, as we can see, they can cancel. And that's going to be 1 and 1. 1 times 13, that's 13. 5 times 1, that's a 5. So this is the value representing tan beta over cos what? Over cos alpha. It can be evaluated direct. It can be evaluated. So it's all about revision. All right. Let's consider another one. Here it was a repetition, guys. You see this thing? It actually just tried to affect my presentation here. Let me check if everything was fine. Sine, cos. All right. Let us try and simplify 3.2. Simplify the following to a single trigonometric term. Sine 180 degrees plus x. All right. So this is from our cast as we are reducing. Remember, this is x. 180 degrees minus x, 180 plus x, 360 degrees minus x. These are positive angles. So 180 degrees plus x lies in the third quadrant. This is not for sine. This is a quadrant for tan. So sine is what? Negative. This is going to give us negative sine of what? Of x. All right. Then cos squared of, all right, let's ignore the squared, but cos 90 degrees minus x. This is part of our core functions. Remember, the sine of x is equal to cos 90 degrees minus x, our core function, complementary angles. So the other one will be x, the other one will be 90 degrees minus x. So the whole of this part is equivalent to sine of x. But it is being what? It is being squared, cos squared, so it's sine squared. All right, plus the sine of negative x. This is a negative angle in the fourth quadrant, negative x. This is x minus 180. So negative x is in the fourth quadrant. And this is the quadrant for a cos. Sine is what? Is negative. So this was going to give us a negative what? A negative sign. So that's negative sine x. Cos squared. All right, let's ignore that. But we have got what? 180 minus x. 180 degrees minus x lies in the second quadrant where cos is what? Negative. So it was going to give us negative cos of x. But being what? Being squared. So you must square that one. All right. So this is where we are. Negative sine of x. Sine squared is the same as sine squared, like this, sine squared x. All right, here I've got plus and minus. That's a minus. Sine x minus, when being squared, gives us a positive. So this cos was going to be cos squared x as a positive. Negative squared becomes a positive. So are we seeing something common between these two terms? This is a term and this is a term. we can say that negative sine x is common. There's negative sine x. There's also negative sine x. So you can actually factor it out, factorize. We can factor it out, factorize negative sine of x. What are we going to remain with? It cancels here. You remain with what? Sine squared of x. Negative to negative, that's a positive. So it cancels. You remain with what? Positive cos squared of x. Are we seeing something common here that we are used to from our trigonometry? Sine squared plus cos squared. This is our Pythagorean identity, which gives us a 1. Remember, that is equal to 1. So it's going to be negative sine of x times 1. All right, so negative sine x times 1 is what? Negative sine x. So this is a single trigonometry that we are going to have, a single trigonometric term. All right, negative what? Negative sine x, just like that. All right, so play around these questions. So that was, this is 3.2, not 3.1. Why am I writing 3.1? This is 3.2 and 3.3. All right, this was just a repetition here, so I'm just gonna use this one. This is 3.3. Evaluate without the use of a calculator. This was all over this one. It was a division. All right, so we can try to apply our reduction concept, guys, as we have these angles. 100, remember, as we consider our angles, this is 0 degrees, counting and going this anti-clockwise. This is 90 degrees, 180, 270, 360. So 100 degrees lies between what? 90 and 180. So it's an angle is supposed to be 180 minus x, where x is what? Where x is an acute angle. So it's 180 degrees minus what? X is a reference angle. That's an acute angle. So to get 100, what are we supposed to subtract from 180? It is simply 180 minus what? 100, which is what? 80 degrees. All right. Then cos 315. 315 is more than 270, but what? Less than 360. And those angles are written as what? 360 minus that. 360 minus what? X. So it's going to be cos 360 degrees minus what is our X? 360 minus 315, that's 45 degrees. So our X there represents an acute angle always, all right? Tan 210. Which quadrant is this? 210 is between 180 and 270 in the third quadrant, and these angles are written as 180 plus X. So it was going to be tan 180 degrees. Which angle are we supposed to add to get 210? At 180, you add, you obtain what? 210. So simply subtract 210 minus 180, which is what? 30. So that's plus 30 degrees. Remember, 180 plus x. Everything over the same thing, guys. Sine 675. This one is more than 360. So you have to subtract 360 here. 675 minus 360 is 315. So it was supposed to be sine 315 degrees, which is found, right? 315, we have it here, guys, for cos. So that is here for this cos. So it's going to be the same, sine 360 degrees minus what? 45, just like a cos. All right. Then cos 150. 150 lies in the second quadrant between 90 and 180. So angles are written as what? 180 minus x. So it's cos 180 degrees minus what is our x? 180 minus 150, that's 30 degrees. all right, times sine 170. 170 is still in the second quadrant again, so it's gonna be sine 180 minus x, our acute angle, which is what? 180 minus 170, which is 10. So it's gonna be minus 10. So we haven't changed anything. If you simplify this, you get back this as they are. We haven't changed anything. But this allows us now to reduce, as we do understand that cos 180 minus x is found in the second quadrant, minus x, and cos is what? Negative. So if it was cos 180 degrees minus x, you are going to obtain minus cos x. So what about cos 180 degrees minus 80? It is going to give us the same thing, negative cos of what? The acute angle. Your acute angle is what? 80 degrees. So that's negative cos. So these are the acute angles, guys. 45 degrees, 30 degrees, 45 degrees, 30, 10. Just like that. So you must consider the quadrant where it is found. All right. Cos 360 degrees minus x, 360 degrees minus 45 in the fourth quadrant, and cos is what? Positive. So it was going to be positive cos of what? The acute angle, cos 45 degrees, times the tan of 180 degrees plus x. 180 degrees plus 30 plus x is in the third quadrant, and that's for tan. So tan is positive. Tan of what? Of 30 degrees. Everything over what? Sine 360 minus 45 in the fourth quadrant, where sine there is what? Negative. So it was going to be negative sine of what? 45 degrees, the acute angle. And cos 180 degrees minus 30, 180 minus x, second quadrant, cos is negative there. So it's going to be negative cos 30 degrees times sine 180 degrees minus 10. This is in the second quadrant, and the sine is what? Is positive. So this is what you're going to have. All right. Remember, guys, from our special angles, sine 45 and cos 45, they are the same in terms of the values. So we can simply cancel those two. We do understand that they are the same. Yes, you can substitute their equivalent from our special angles. We know this is a square root of 3, square root of 2 over 2. So they are just the same. You can cancel sine 45 and cos 45. They are the same. All right. Also, the sign here, negative, negative, I'm going to cancel. So I was going to remain with negative cos 80 times tan 30. So tan 30, you can use your special angles. You can even just use your calculator. No one is going to know that you have used your calculator, guys. All right. So tan 30, opposite over what? Opposite over adjacent, 1 over square root of 3, which is the same as square root of 3 over 3 if you rationalize. So tan 30, that is square root of 3 over what? Over 3. Everything over what? Remember, negative, negative, we cancelled. You are now left with cos 30. Cos 30, adjacent over hypotenuse. So that's square root of 3 over 2 times the sine of 10. These are not special angles, guys. 80 degrees and 10 degrees. They are not special angles, but what is that we can do? We can try to rewrite these in the same manner from our complementary cofunctions. Remember, 80 plus 10 gives us 90 degrees. So it means if these two angles are giving us 90 degrees, they are complementary angles. And from complementary angles, the cos of x is equal to the sine of 90 degrees minus x. So if you've got angle here, this is going to be 90 minus that. Like cos 80 degrees is going to be sine 90 degrees minus that angle 80 degrees. So this is going to give us sine 90 minus 80 is what? 10 degrees. So cos 80 degrees and sine 10 degrees, they are the same. So you can write one as another. So I'm just going to rewrite cos 80 as sine. So it's negative sine of what? 10 degrees times square root of 3 over 3. All right. That is everything here over the square root of 3 over 2 times the sine of 10. So this is going to help us to cancel because we can see that they are exactly the same. So this was going to give us negative times here, negative square root of 3 over 3. Everything over what? Square root of 3 over 2. Remember, when dealing with a division, you're going to introduce a multiplication, and what happens after that is you invert the second fraction, you swap those two. So it was going to be 2 over the square root of 3. All right, so that's it. Square root of 3, square root of 3, that is going to give us what? Negative 1 times 2, negative 2, 3 times 1, which is 3. So those two can cancel and give us what? A 1. But you can now multiply the numerators together, the denominators together. So that's minus 2 over what? Minus 2 over 3 at the end. So you see, guys, that is trigonometry. Must play around. Understand all the basics. Understand all the basics. All right. So like I said, this was just a repetition for 6 marks. But for 6 marks, that's it. That's it. All right. It just needs revision. Just needs revision. So guys, please do revise. So on 3.4, you were given this here is equal to tan of theta. You're supposed to prove that it is equal to tan of theta. All right. So guys, I'm very sorry for these repetitions that occurred here. But anyways, let's see how we can play around with our proving. We need to prove. So I'm just going to take the left-hand side, the one that is more complicated. All right. 1 minus cos squared. So like I said, I'm going to take the left-hand side. 1 minus cos squared of x into the tan of x plus the cos of x over the sine of x. All right. It must give us a tan. By simplifying this, we must obtain a tan. All right. Tan of x. All right. So remember our Pythagorean identities. The sine squared of x plus cos squared of x, which gives us a 1. If we take the cos squared, that will be a negative there. So meaning to say, sine squared x is actually equal to 1 minus cos squared of x. So where we see 1 minus cos squared of x, we're going to put what? Sine squared there. So this whole part was going to be what? The sine squared of x. All right. Tan is same as what? Sine over cos. You can also change that one. Sine of x over the cos of x plus what? Cos of x over the sine of x. All right. Let us simplify our bracket. So this is sine squared of x. Here we're going to add. So we're going to need the LCD of the given denominators, which is cos x, sine of what? Sine of x. Okay. Dividing here, cos x and cos x, they were going to cancel. So you remain with sine times sine. All right. So it's cos x, sine x over what? The cos of x, the denominator there. So these we're going to cancel. You remain with the sine of x. which multiplies the what? The numerator. So sine times sine is what? Sine squared of x. The same here, sine and sine we're gonna cancel, so you remain with cos, and cos times cos is what? Cos squared. So that's cos squared of x. So guys, this is the exact identity that we have here, which gives us what? Which gives us a 1. Sine squared plus cos squared is what? Is a 1. So that was going to be 1 over cos x, sine of what? Sine of x. So this is same as over 1. So it allows us even to divide sine x into sine squared x is going to give us 1 sine x. So multiplying the numerators together, sine x times 1, that's sine of x over what? 1 times cos, that's the cos of x. Remember, sine over cos was taken from a tan, so this is also the same as what? As the tan of x. And that is exactly what we have on the right-hand side, the tan of what? The tan of x. All right, then after that, they wanted us to solve for which value or values of x in the interval from 0 to 360 is the identity in question 3.41 undefined. For you to consider this condition of being undefined, you must have a fraction a over b. And for this fraction to be undefined, the denominator is supposed to be equal to 0. Remember, a over 0 does not exist in our mathematics. It's not about the numerator, it's about the denominator. So you must correct that part in your memo because they used the numerator where we have got a fraction. All this whole identity that we see here, this whole identity is the one that reduced to what? To sine over cos. So you can continue from that where you have what? A fraction. Remember, tan is the same as what? Sine over cos. So you're going to use this fraction. That is where I'm saying that for this to be undefined, from our concept of using a fraction where I was using this a over b, the denominator is supposed to be equal to 0. So meaning to say that's our 3.42. 3.42, our denominator cos of x must be equal to 0. Then we can solve for x in the interval that we are given from 0 to 360. All right. So you're going to need the reference angle, which is, all right, for 0 degrees, there's actually no need, but that's a cos, which is 90 degrees. So remember, 0, guys, can you say 0 is positive? Is it negative? There is nothing like being positive or negative. But according to our main angles, this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. Which one will give us a 0? There is 90 degrees that we already have. The other one is going to be 270. Or you can use your calculator to verify. Cos 180, we can see that it's minus 1, not a 0. Cos 270 degrees is what? Is equal to 0. So that's 90 and 270. So therefore, from 0 to 360 degrees, our x is supposed to be 90 degrees or 270 degrees. That's where this is going to be undefined. The denominator is the one that you work with. It must be what? It must be equal to 0. All right. Now moving on to 3.5, and it was just a continuation. Guys, I don't know what was happening here. But anyways, this is our 3.5, the last part of the question. Given that sine theta is equal to minus 6k over k squared plus 9. All right, this is the sine of theta. And theta is taken from from 90 to 270 degrees. And k is what? Greater than 0 but less than 3. K is found in within these values. So the question was, all right, in terms of k, all right, I think like there's a statement that was left here. Determine the value of tan theta. All right, so here guys, sorry for that. It was supposed to be determine the value of tan theta plus that, right? Determine the value of what? Tan of theta plus 1 over cos theta in terms of k. Your answer must be a single fraction in its simplest form or lowest form, all right? So we must determine this trig here. All right, how can we determine this, guys? We must have we must work with our triangle where we can find tan theta and cos. But look here, they gave us sine theta as a term, like given unknown values. We're just going to use those unknown values. So this is negative 6k over k squared plus 9. This is definitely positive, and this is negative. So positive, I mean negative divided by positive is what? Negative. So you must not to say, is your sine of theta a negative or a positive? This one is a negative. And we are told that our theta must be taken from 90 to 270 degrees. This is 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. From this range that we are given, 90 to 180, I mean 90 to 270, where is it that sine is what? Negative. Remember from our cast concept, sine is positive in the second quadrant, but in the third quadrant, it is what? A negative. Remember, from 90 to 270, guys, these are the quadrants that we are working with. We need a condition that satisfies one, the interval from 90 to 270, but our sine is negative. So that was going to be the third quadrant. This is where your triangle is going to be, where sine is what? Is negative. So according to the ratio of a sine from our SOHCAHTOA concept, sine is opposite over hypotenuse. So this is opposite and this is hypotenuse. So according to our angle, the opposite is negative 6k, and this is our hypotenuse, k squared plus what? Plus 9. So definitely you are going to need to determine the third side, which is in terms of k. All right, so how can we determine that? Remember that r squared is equal to x squared plus y squared. All right, so we need to calculate our x. So that's gonna be r squared minus y squared, or you can just substitute as it is, guys. Your r is what? Your r is the hypotenuse, k squared plus what? K squared plus 9. So k squared plus 9, but it must be what? It must be squared. All right, is equal to x squared plus y is what? Minus 6k squared. All right, so we need to solve for x. All right, so to solve for x, this is, all right, this is from our a plus b squared, which gives us a squared plus 2ab plus b squared. That's the first term, k squared. And this is 9. This is our a and b. So k squared, a squared, you must square it. K squared, but must be squared. So it was going to be 2 times 2, which is k to the exponent of what? K to the exponent of 4. All right. Plus 2ab. That's 2 times our a is k squared, and our b is what? Our b is 9. So 2 times 9, that's what? 18. So it was going to be 18 k squared plus b squared. Our b is what? Is 9. And 9 squared is equal to what? 81. All right. So this is it. That's equal to x squared minus 6 squared is going to be positive 36. k squared. Also k is going to be squared. All right. That is where we are. That is where we are. And what we need is to have or to solve for what? To solve for x. So I'm going to take the 36k squared to the other side. So it was going to be k to the exponent of 4. 36 is going to be a negative. So that's a like term to this 18k squared. So you're going to subtract 36k squared. 18 minus 36, that's negative 18 k squared plus 81. And this is equal to x squared. So we need x. So we have to solve that, factorize this part here. To factorize here, guys, it is just like k to the exponent of 4 is same as k squared, like this. All right, minus 18k squared plus 81. So what we can simply do here is to focus on that k squared. All right, the coefficient is 1. So we can simply factorize. You have two brackets, and that's equal to x squared. So that will be k squared, k squared. Then what are the factors of 81, which will give us negative 18? We have to factorize 81, negative 9 and negative 9. If you multiply this, you get 81. If you add, you get negative 18. So that's negative 9, negative 9. So simply, it tells us that these are two brackets, guys, that are the same. So it can be written as x squared minus 9 squared. This one, these are two brackets. So that is equal to x squared. So to find x, introduce the square root. All right. We need to find what represents x in terms of what? In terms of k. So our x was going to be plus or minus the square root of this. Square root and squared cancel. So you're going to remain with what? K squared minus 9. So our x, where is it found? It is on the left side. So that's a negative value. So on this one, our x, we are going to choose, we are going to pick the negative one because of where our x lies. It lies on the negative region. So that's negative what? K squared minus 9. So this was going to give us negative k squared minus 9. So that was it. We had to find the third side, just like before. When you are given these as numbers, guys, but this time they gave us what as unknown values. You play around that. So what will be the value of this part that we are given? Tan theta plus 1 over cos. So we can find those, that part, guys, by simply applying this, all right? Tan of theta plus 1 over cos theta. According to our theta, this is the opposite adjacent hypotenuse. So tan theta, we are still on our SOHCAHTOA concept. So tan is opposite over adjacent. Opposite minus 6k over the adjacent. Our adjacent is negative k squared minus 9. All right, plus 1 over cos theta, where cos is adjacent over hypotenuse. So it's 1 over adjacent minus minus k squared minus 9. This is over what? The hypotenuse. Adjacent over hypotenuse. Our hypotenuse is what? K squared plus 9. So this was what you were going to have. And this can be simplified, guys, as we can see here. We can just simplify. Negative cancels. So it was going to be 6k over what? K squared minus 9. All right, there we have got 1 over, this is the reciprocal, 1 over A over B. This is the reciprocal, which is just interchange. It's going to be b over a. You interchange that. So this was just an issue of interchanging. So it was going to be k squared plus 9 over this one minus k squared minus 9. But we cannot write the negative in the denominator. It is going to combine with this one, and it will be negative. So it was going to be negative k squared plus 9 over what? K squared minus 9. This is where you are. And according to our simplification, we do understand that these denominators are the same. So when working with the same denominators, guys, you can easily combine the numerators together. So it is going to be 6k minus, take note, the minus is affecting the whole of this part, this expression of k squared minus 9. So you must, k squared plus 9. So you must open a bracket for that so that you can simplify this one further. 6k minus, we're going to affect here negative times k squared. That's negative k squared. Negative times negative here, times positive, that's a negative 9. That's a negative 9 over k squared minus 9. All right, we are still on our simplification. This is same as minus k squared plus 6k minus 9, where k squared is affected by a negative. So we can factor out the negative so that this becomes positive. So the moment you factor out that negative, this will be negative divided by negative, positive k squared. Positive divided by negative, negative 6k, negative 9 and negative positive 9, like this. Everything over what? K squared minus 9. So we can simply factorize and see what's happening here. These are just going to be two brackets here. The coefficient of k squared is 1. So meaning to say this is going to be k and k. Factors or products of what? Of 9, which adds up to negative 6. That's negative 3 and negative 3. There are so many factors of positive 9. So many factors. But the one that when we add, we are going to obtain negative 6 is what? Negative 3 and negative 3. So this was going to be negative 3 over what? K squared minus 9, a difference of 2 squares, where you need the square roots. So square root of k squared, that's k. Square root of 9 is 3. One subtracts another bracket. It adds these square roots that we have. So this was going to be simplified further. K minus 3 cancels. So you'll be left with a negative k minus 3 over what? K plus 3. Just like that. All right, so this cannot be simplified further. Yes, you can expand by the negative, but you won't be able to cancel anything. So that was the value. That was it as a single fraction from here. The value of what? Tan theta plus 1 over cos theta in terms of what? In terms of k. And your answer must be a single fraction in its simplest form. So this is a single fraction in the simplest form. As we can see, we cannot simplify any further. So you must simplify up to the extent that you cannot simplify any further. Like I said, yes, we can expand by negative. It's going to be negative k plus 3 over k plus 3. These two cannot cancel, guys. This is negative k. So you just have to leave your answer as it is. So that is it. These are the typical questions that you might be given. Yeah, sometimes it can extend to be a tiresome question like that. So it was out of 30 on question number 3, making up this to be the end. This is the end of our revision. So guys, let me know. The comment section is there. Let us communicate if there is a part that you do not understand, so that we can have more revisions along the way. All right, we can have more revisions along the way. Try to work out as many question papers as we can. All right, if we have got any other question paper, you can also send it to my WhatsApp. All right, you can check the description of the channel so that you can send your questions. We do revisions on those on another platform. All right, so that is it, guys, till we meet again.